Okay, let's look at the homework 8.2, problem number 9. Right, one use the Simpsons rule with n equals 10 to approximate the area of surface of revolution. Right, so let's do that. Alright, so the function is given, and let's try to set up the integral first. Alright, so surface area S is going to be, right, remember that we have a 2 pi, right, the integral is going from 0 to 1, so that's not hard to figure out, right, then radius, right, since this is rotated about the x-axis, so the function value is going to give you the radius, so we have a function which is 4x e to the x, right, so that will be the radius. Then what we need to do is we need to multiply by the arc length. So arc length formula. So it's going to be a square root of 1 plus, right, we need to find the derivative. So find the derivative, dy over dx is equal to, right, 4 is just a constant multiple, put it here. Then we can use the product rule. Derivative of x is 1 times the second guy, e to the x, plus first guy, and the derivative of e to the x is luckily exactly the same thing. Right, so you will get 4 times 1 plus x. Then we can factor out e to the x because it's in common. Right. So we have to square that, so 4 squared would be 16. Then you have 1 plus x quantity squared. Then e to the 2x, because you have to square that. Right? Then we have a dx. Alright, then what we want to do is we want to approximate it using S sub 10, Simpsons rule. Right? So I'm going to call this guy f of x, so it's all the integrand including the 2 pi, so I'm going to just include all of that, and I'm going to call that guy f of x. Right, then this can be approximated by, so it's approximated by s sub 10. Right, so Simpsons rule, right, we have to find the delta x first. Right, so delta x is always b minus a over n, right? And in this case, b is 1 right here, minus a is 0 right here, all right? And n is given in the problem, n is equal to 10, right? So divide by 10. So this is just going to be 1/10, right? So Simpsons rule goes 1/10 delta x divided by 3. That's part of the Simpsons rule. Then first one, so we have an interval from 0 to 1, right? Right, so 0 to 1. And n is 10, so we divide it into 10 pieces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can see that the next one is 0.1, 0.2, and so on. Right? So we have f of 0 plus 4 times f of 0.1 plus 2 times f of 0.2, and then you just keep on doing it 4 times and so on, and second to last will be 4 times f of 0.9 and plus f of 1. Right, so let's compute this value using Geogebra. Alright, so first I have to define a function. F of x is equal to, right, it's a 2 pi times, actually 2 times 4, so it's going to be, I'm going to put the 8 pi times x times e to the x times square root of 1 plus 16 1 plus x squared. Then you have times e to the 2x. Right, so let's hit enter. Alright, so you have 8 pi x e to the x square root of 1 plus 16 quantity x plus 1 square e to the 2x. Alright, so that's the function. Then we're going to do, alright, 1/10 divided by 3. So I'm going to put the 1 over 30. Alright, that's easy enough, right? Then you have f of 0 plus 4 times f of 0.1 plus 2 times f of 0.2 plus 4 times f of 4 times f of 0.3 plus 2 times f of 0.4 plus 4 times f of 0.5 plus 2 times f of 0.6 plus, so actually there's no 2 there, 2 times, right? Then 4 times f of 0.7 plus 2 times f of 0.8 plus 4 times f of 0.9 and plus f of 1. Alright, then hit enter. Alright, and we need 6 decimal places, so go to option, rounding, and I guess we have to do 10 decimal places. Alright, so we get 372.400996. Alright, so let's type it in. So I'm gonna go here. Alright, so let's type that in. Alright, so we got 372.40 and 09 and 96. Alright, so let's just check submit for testing first. Alright, I came back and it looks like we got this one correctly. Alright, then we're going to do a calculator approximation. Let's bring out the Geogebra again. Alright, so what we have to do is we want to integrate into, integral. Alright, so function is already defined, so I'm going to put f of x. And starting value is 0, so this is a lower limit. And upper limit is 1. Alright, then you hit enter. Alright, and it's thinking. Alright, it came back and we have a 372.376143. Alright, so let's type it in. Alright, so we have 372.3761 and 43. Alright, so let's submit for testing. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.